Test, test, 1, 2, 3. Test, test, 1, 2, 3. Hello everyone, I'm Ryan, the WoMaster Sales Director. In today's webinar, we're going to share with you about the Wi-Fi mesh introduction. The introduction of the WoMaster Wi-Fi mesh access point WA512GM series. Features of the Wi-Fi sound mesh, and the last part is the demonstration about the Wi-Fi mesh network. We will show you how to configure and some scenarios. Today, we are using the YouTube Live to broadcast during the presentation. If you have any questions, please type it in the chat room. We will reply after the presentation. First of all, we're going to explain what the mesh network is. In typical topology, like tree or star, they have the different tiers. Each node can communicate with the upper and the lower the tiers only. However, for the mesh network, it doesn't have the sophisticated tiers. This kind of the topology is just like a web. Each node can find the best routing path to deliver the data to the destination. In this way, the performance in the whole network is enhanced and setting up the network is easy. There are 3 roles: router, node, gateway, and the end node. The gateway is an entry of the old subnet. In here, it's just like the CAP. It stands for the central access point. The end node, the end of each path is end node. Usually it connects to the terminal devices, just like the cell phone, PLC, or anything else. And the others are the router node. Before diving into the Wi-Fi mesh, please let me show you our Wi-Fi mesh wireless access point router WA512GM series. Now we have the 2 models. One is for the indoor, another one for the outdoor, supporting the IP67 protection so that they can fit into the different environments. We are using the Qualcomm solution, dual band. It supports the 2.4G and 5G. Wi-Fi 802.11 the AC Web 2 up to the 866 Mbps, compatible with the ABGN. It supports the Wi-Fi sound mesh. It's today the major topics, and we will talk more detail later. And the users can use the SyncMaster cloud platform, then the utility WoMaster, and the MMS NetMaster to manage with the Wi-Fi devices. Of course, cybersecurity, MQTT, and the redundancy are also supported. It's a same-sized DIN mounted design, wide temperature, -40 to the 70 degree, and PoE, the power input, 802.3 AF PD. It also supports the wayside certification EN 5121. In this page, there are some features and details for your reference. We've gone through the spec in the last slide, so please take a look. After the presentation, you can pause to check the details, or just download the datasheet from the WoMaster website. Here is the Mesh Wi-Fi structure built up by the WA512GM series. There are two parts in this topology. In the right-hand side is a mesh network. There are 5 mesh devices with the OMI antenna in it. The maximum distance is around 50 meters. And there is a CAP to connect to the WAN. It's also a portal of the subnet and response for the SS outer network. Beside the CAP, each node can communicate with each other with the best efficient path. The whole network is built up automatically. According to the technical suggestion, the maximum layer is not over the 7 hop layers. Here is the basic mesh network. In the left-hand side, even the maximum distance is around 15 minutes with the OMI antenna. Sometimes, users need to extend the longer distance. In this case, we can use the WA512GM with directly the high-gain antenna to extend the communication to the 1 or 10 kilometers in this way, so that we can connect two separate the network together. Hence, mesh network is more flexible and extensionable. Now, we are talking about the features for the mesh network in the following slides. We're going to talk about why we use the mesh, easy setup with the single SSID, and the good performance. What kind of the features belong to the Wi-Fi sum, like the band streaming, AP streaming, self-healing, and stringless roaming. We will talk the details one by one later. And with these features, Wi-Fi sum can provide an efficient and robust mesh network. And the last part is the demonstration by the technical support Patrick. He will show you how to configure and how to set up a typical Wi-Fi mesh network. In traditionally Wi-Fi AP client architecture, Sometimes engineering will need to plan the different SSID to avoid the interference among the different access points. It increased not only the capacity of the whole network and the configuration for the Wi-Fi coverage, but the user-friendly. However, by mesh network, you can use the one SSID to cover the field size. It's simpler to build up the whole network. Moreover, when the Wi-Fi devices are moving, like a cell phone, users don't need to do the roaming or switch the SSID manually. They will find the best routing to communicate as the previously mentioned. There is a comparison table between the mesh and the AP client architecture. Mesh just needed one SSID. It can do the configuration and the management the network by itself. Users don't need to do it manually. Moreover, each node can coordinate with each other, not like the AP is standard architecture. So we can see easy is the major difference. For mesh network, users can use the one SSID to cover the whole network, and this network can be configured and managed by itself. It's very easy and fast for user. We don't need to set up the one by one. It reduces the capacity of the network to build up. With self-management, each node can know the status of the other nodes, so it can find the best routing paths and improve the performance of the network. We will talk more in the next page. Other benefit is the higher the performance for the WA512 GM series. In the typical architecture, if the single band, the throughput will be shared by the uplink and downlink at the same time, so that the performance is going the worst by each hop. Roughly, each hop costs the 50% lost. It means more hops getting the more the speed lost. In this way, users cannot get an efficiency the user experienced. However, WA512 GM series supports dual band, 2.4G plus 5G, and a mesh network. It will coordinate and manage the performance by itself to avoid the data loss. It will adjust how to reach the mass utilization of the network, maybe like the uplink by the 2.4G and the downlink by the 5G with the two different bands. The network can provide the full data usage. In this way, it can remain the better the performance in the whole network and offer a good user experience. Moreover, mesh network can do the self-organized and the network bands training. There are three scenarios as follows. The mobile devices need to communicate with the outer network via the CAP. First, if the one device would like to connect to this network, the mesh mechanism will detect which band will be better, 2.4G or 5G. If 5G is better, it will switch to connect devices from the 2.4G to the 5G to keep the better performance. Second, if your device is mobile one and the reachable distance of the 2.4G is longer than the one of 5G in the technical speaking, so that once the devices move to the place where it can reach the 5G network, it can change to the 2.4G to keep the connection. The third one is about the interference. Usually, there are many different RF communication in the 2.4G band, maybe like a Zigbee, LoRa, or anything else. Sometimes these signals will interfere with the quality of the signals. Under this kind of the condition, the connection will be changed to the 5G band to remain the best signal. Regarding the above the situation, the network can be managed automatically. Users don't have to do it manually and can get the better performance. Mesh network also supports the AP steering, as the previous mentioned. If without the AP steering function, all devices just connect the one with the better signal from its angle, not from the whole network. However, it cannot promise the best performance for the whole mesh with the AP steering features. It will adjust to find the one with the best performance to make sure the mesh network can have the optimized utilization to avoid the condition all devices access the one access point. Based on the Wi-Fi usage condition, AP steering measured to provide the maximum utilization to each AP. They can get the best performance. Mesh network can also manage its network by itself. We call it as the self-healing. In the initial network, usually it can connect to the CAP with the less hopped path. But if any of the devices fail, it will recover the connection to the others of the alive of the mesh the devices connected by the other paths. We take this scenario as an example. The cell phone can access the WAN through the CAP, and the path is alive. However, one device is broken. The mesh network will coordinate a new path to access the CAP for the cell phone. Therefore, the cell phone will find the CAP by another path. It's automatic, so we call it as the self-healing. Hence, once one mesh device is broken, the mesh will offer another path to access CAP. And we still can keep the communication for the other mesh devices automatically. The engineering just replace the failed one to recover the original topology. It's easier and flexible to maintain this network. In this page, it's about the network streamless roaming. By these features, the mesh network can support the faster roaming and the short roaming time to make sure the whole network connected. You can see what kind of the open standard WA512GM supports to achieve the faster roaming among the different mesh devices. Furthermore, WA512GM series supports these standards to speed up the roaming time to make sure the mobile devices can communicate through the best and efficient paths. Each roaming has three status. Before the roaming, 802.11 radio resource measurement. It sends the client list of neighborhood to reduce the scan time. Before the topology changed, each node is informed which the nodes besides. If any change, it doesn't need to rescan. When trigger the roaming, 802.11v BSS transition the management frames. It helps to find the best new AP because each node already knows which AP has the better signal. According to this, they can know how to change to the suitable one. During the roaming, IEEE 1905.1 enabled the AP auto configuration and join the network with a unified security process to reduce the authentication time. So we don't need to waste time to redo it. With this open standard, mobile devices can switch the faster to the best path. By these features, it can provide the short network roaming time and let the user keep accessing the network without the switch time. Multiple backhaul links can provide the better performance and the redundancy for the backbone. In a single backhaul link, once one band has problem, the whole network will get a problem as well, and it can provide a better performance to users. With the multiple backhaul link, users can have the 2.4G and the 5G as the backbone at the same time. Once one of them fails, it can switch to another one for the redundancy. Another benefit is that the mesh network will balance the throughput between the 2.4G and the 5G. It will choose the better the performance one as the previously mentioned. Users don't need to be worried if one of the band has a problem. The network is still keeps. There is a comparison table between the WA, the 512GM, the Wi-Fi sum, and the third-party mesh. As you can see, more features are supported, like the streaming down the 11 kV clients, APS. It can help to find the best path, multiple backhaul links, and others. With these features, the WA512GM can provide higher performance and network utilization. And the Wi-Fi sum of the WA512GM series can also provide this advantage: algorithm maturity, multiple backhaul link, airtight fairness, IP streaming and band streaming all belong to the algorithm maturity as previously mentioned. And we just mentioned the backhaul link. Moreover, airtight fairness can make sure that each device can access the throughput fairly. With these features, it makes sure that some legacy devices will not occupy too much the IF bandwidth to access the data to delay the network performance. With these three features of the Wi-Fi sum, algorithm maturity, multiple backhaul link, and airtight fairness, the whole mesh network can be enhanced and optimized. We've discarded individual features in the previous slides. WA512GM series can be configured by the web console and the utility. Later, our technical support Patrick will show you how to configure by the web console. Here, what I'm going to do is show you how to configure by our utility WoMaster. The same concept is implemented to the web console as well. Here is an easy function in the WoMaster. We called it as the quick mesh setup. First, we need to power on all of the WA512GM devices, and its the default setting is RE mode. RE means the range extender. Second, we need to pick one the RE from them as the CAP. Connect to which one you would like to be by the Ethernet. Enable the CAP checkbox as this photo and apply it. Third, we scan all of the devices. You will find all of the devices connected as the mesh network. Last, if you would like to change the SSID and the PSK and apply it, then just change this and apply. Then you can bring these devices to the field site for the installation. Sometimes, if users would like to add a new CAP or RE, please also connect the devices by the Ethernet. And just change the SSID and the PSK. Then it can be a new one to add the listener mesh. Don't forget the role in this network. Please also set it as the CAP or RE. Here is about how to configure by the utility. Now, our technical support Patrick will show you how to show you the hands-on about the configuration and the demo for the WA512GM series by the web console.
Okay. At first, this page shows you our demo part today. So you can see we have 5 pieces of WA512GM, and the CAP is .10.2, and we have 4 range extender, .10.4, .10.5, .10.6, and .10.7. Okay, so we will show you how to configure the mesh of the WA512GM. So the first, you can see now we log into the .10.2. This one is the CAP. After logging, we select the wireless LAN and choose the wireless LAN settings and mesh settings. First, we need to enable the mesh. Then we need to choose the device, is CAP or RE. The CAP means the central access point, and the RE means the range extender. And we choose CAP. Okay. So in the right side, you can see this one is the RE. Okay, we choose RE in the right side. Okay. Then we need to select the channel of the wireless LAN 1 and the wireless LAN 2. Okay, so you can see the wireless LAN 1 is 2.4G interface, and the wireless LAN 2 is 5.8G interface. If you select RE, so you don't need to choose the channel, the RE channel will follow the CAP. Okay. Then we can set the SSID and the pre-share key of the CAP. The pre-share key need at least 8 characters. Okay, so now you can see both the CAP and the RE has the same SSID and the pre-share key. And after configuration, you can click submit to save the configuration. Okay. Then after configuration, we can go to the mesh status to check the status. Okay, so you can see the first in the local status, the interface display the MAC address and the channel of this WA512GM. And in operation mode, the WA512GM is set as CAP, and the SSID is WA512GM underline mesh. And the uplink status is disconnected. It means the CAP has no uplink to internet now. But if we go to the mesh status of the RE, you can see the uplink status is connected. It means the RE has uplink to another RE or uplink to CAP. Okay. So you can see the hop to CAP. Hop to CAP is 0. It means the this WA512GM is CAP itself. And in right side, you see the hop to CAP is 2. Means this RE is uplink and 2 hop to the CAP. And you can see the downlink hop 1. This field will display all the MAC address and the channel of one hop downlink range extender. So you can see now have 3 RE downlink. Okay. So in the devices table, this table will show you the detailed information of entire mesh topology. You can see the index display the number of the WA512GM within the mesh group. Okay, so we have 5 WA512GM in our topology. And the ME means which WA512GM we are logging to check information now. Okay, so in this page, in this web GUI, we log into the CAP. So CAP will show ME. And the mode display the rule of this WA512GM within the mesh group. And the IP address display the IP address of the WA512GM. And the MAC address display the MAC address and the channel of 2 wireless interfaces each WA512GM. And the string direction were displayed on the ME. Okay, so you can see because the ME is CAP now, so all the other WA512GM is downstream. Okay, and you can see the hops. All the RE is 1 hop to CAP except .10.7. Okay, and the uplink status display the MAC address and the channel of 2.4G, 5.8G of uplink WA512GM. Okay, so now you can understand the .10.7. .10.7 is uplink to the .10.4 and the .10.4 uplink to the CAP. Okay, and the clients display the client number of ME. You can only see the client number of ME. Okay. Okay, we're back to the PowerPoint. We will introduce how to use the front panel LED to help you check the connection in this page. The RA LED show you the mesh status if RA is green on, means the uplink existing, both the CAP and RE. And if RA is green blinking, means there are no uplink in this WA512GM. Okay. And the RB show you the signal strength to uplink. If RB is green on, means the signal strength is strong. The value is bigger or equal than minus 65 dBm. And if the RB is green blinking, means the strength is weak. The value is less than minus 65 and bigger or equal than minus 75 dBm. And if RB is off, means the signal strength is very low. The value is less than minus 75 dBm. In this case, we will suggest to change the position of this WA512GM. Okay. So you can see our demo topology include star, daisy chain, and the tree topology. The IP address .2 and .4, .5, .6 are star topology, and the entire topology is tree. Okay, and the IP address .7 uplink to .4, and the .4 uplink to the CAP .2. So .2, .4, .7 are the three WA512GM is daisy chain topology, and the entire topology is tree. Okay. The topology, of course, the topology is dynamic, depend on the WA512GM position. Okay, it's flexible to deployment, and now you know it's also easy to configuration. Okay, that's all for today's demo.
Okay, thanks for the Patrick's demo. It's today's topic. We introduced about the WoMaster Wi-Fi mesh solution and the WoMaster Wi-Fi mesh access point WA512GM series. We will confirm the topic shortly for the coming webinars. Just contact us. And please subscribe the WoMaster YouTube channel to get more related information. Any question? Okay, thanks for your time to join. See you next time.